So, welcome to my forensics presentation on the Fast and the Curious. Those of you familiar with my presentation style will probably be a little disappointed because it's not going to be as dynamic. By dynamic, I mean HackerCon. So, the nice thing here is that I finally get to come out and say, I'm representing my company. Everything I say is the opinion of my company. We back all of this. We disclaim nothing. There's no deniability here. And unfortunately, it also means that I won't be using my usual assortment of images, although I did my best to try and find stuff that would keep everybody awake at 9 a.m. In case I forgot to say it, which I did already because I wrote it in my notes, thanks for having me here. I really appreciate it. Appreciate your time. I hope I can convey something of value with this presentation. Forensics is hugely a team effort, and I certainly wouldn't be here without all of the people that went before me and made what we do possible, because I certainly couldn't have done it. So that being said, here's the little about me slide. Brian Martin, blah, blah, blah. I own Digital Trust, started forensics in 1984, which is way before a lot of you were born. Founded the Digital Trust company in 2009, and there's the URL if you ever want to hack my website. Please don't. So what we're going to talk about specifically today is performance measurement, throughput science, efficiency, competition, and standards. That slide right there surprises some people. Like, you can put text on a slide? Yeah, I can, when I have to. Not very often. We're going to do the presentation a little backwards so that those of you who don't want to hear my patter and wade through all of the graphics and the boring data and process discussions can leave in like 5 minutes and go find some Starbucks or something. After that, it's going to be data, facts, dry boring, talks about process and how to get things done forensically. Okay, so here's one of the things that I'm here to gripe about. This is the theoretical max data transfer speeds of various bus types. Source, Wikipedia. Theoretically, you can get 8 gigabytes per second, or gigabits per second. That right there, the difference between gigabits and gigabytes, that's just such a joy to deal with. PCIe 3 should be the fastest thing we have going for us at 8 gig. You rarely see that, and testing PCIe by itself is really difficult because it's a bus. You have to plug stuff into it. Well, all of the stuff that you plug into PCIe is something else and has bigger limitations. So testing whether or not a particular motherboard has a quality PCI bus is difficult because you have to isolate it. SATA 3, a little easier to test that. You're supposed to get 6 gigs. Yeah, right. But you can at least, plug that into a bus that's theoretically faster, and you should see 6 gigs. You shouldn't be able to max that out if there's at least a 20% difference, which here there's a 25% difference. And then the rest of the bus is on down the road there. So this is what you get in real life. Come on. Give me text, yes. ATA 133, also known as IDE, the old pin, 40-pin Molex connectors. Not Molex, whatever it was called, but 40-pin connectors. The blue is what we're supposed to get, the red is what we actually see, and the yellow is the total bus bandwidth that we think is available, which is, if you're paying attention, twice what the red is. Because if you're talking on a bus, you have to say something and then you have to hear something back. Specifically, what we're talking about at this point is when you're transferring data from a drive to a drive across a bus, you've got both of the drives trying to talk at the same time, so we'll get into it more later. But the problem here is that this red bar, which is what we're supposed to see, isn't anywhere near halfway in any of these or something like that one. That's a problem for forensics people because, and mostly on the commercial side, we copy terabytes of data back and forth and back and forth. We're harvesting 20, 30 drives it's a big pain in the butt. I imagine it's less of an issue for LE, especially since you guys have, you know, standards and processes, and you're going to plug in a firebox, you're going to plug in a Cellbrite, this is how you're going to do it, and it's this drive and this laptop, and that's it. On the commercial side, we take an entire building, and then we have to process all of that. It's a pain in the butt. So speed is really important to us. And then making things worse is what you stick on the end of it, all of the differences that you get with the devices that are hanging off the ends of the buses. This is a little extreme. We went and pulled some old IDE drives and ran tests on those, and depending on when the drive was made, this, for example, is a very old drive. Slow as heck. It's probably ATA 33. One of the original older IDE drives. And then the newer drives are faster, they have better caching, that kind of thing. But you get this everywhere, not just with IDE. We recently replaced the USB 3 PCIe interface cards. We're getting a depth on the data that goes with that. And just in the year that it took us to conduct the experiment, the chip manufacturers had changed their chip versions, and we were getting double the throughput that we got a year ago. And this makes really doing experiments a pain in the butt, because you're trying to compare apples to apples. Okay. So you like this one? We were having some difficulty getting Google to play with the charts like a nice person. So we're going to go look directly at the data now. So Google will bring up, there we go. Okay. Slide it up here. This is not the slide I want. Sorry, we're on the Wi-Fi. Oops. Okay. So here, why don't you show them that? Google. There we go. Okay, so this is the type of thing I'm talking about, where we've taken a slide that doesn't fit on the screen and tried to squeeze it on the screen. There we go. We've taken an array of technologies here, Seagate's, Western Digital's, Toshiba's things, and we're doing USB testing. We've got main boards. We're doing bus testing from SATA 2 to SATA 2, from SATA 2 to SATA 3, from PCI to SATA 3. We're generating tons and tons of data. This stuff is not free. It's not easy. You see some of the figures that we get here. Everybody recognizes this. It's straight out of Linux time command. Just timing the testings. But generating all the data is difficult. There's going to be boring statistics and figures. All we're doing here is showing you that we actually did generate data for this. So when I talk about the speeds and stuff, we're not just pulling this stuff out of the keister. It's real. Different pieces, different testings. Designing the tests alone is a pain in the butt. But one of the cool things that happens when you actually sit down and test this stuff extensively is you find interesting data. Going to a Caltech is 30% faster than coming from a Caltech. 30% a third. So if you've got to copy 20 2-terabyte drives, which way are you going to go? You want the fast one. That's going to save you 20 drives, 2 a day, 4 days of copying. It's not like it's work lost, but you get to finish the job that faster, which means you get to build a client that much faster. So it's important to us on the commercial side very much for a variety of reasons. Okay, we can come back and play with the data some other time. All right, so this is the problem here. They're selling us this, but what we're getting is this. And that, if you don't recognize it, is a Trabi. Oh, my bad. That's a Trabi. Anybody know what a Trabi is besides me? Come on, some of you guys are old enough. It's an East German car from when there was an East Germany. And West Germans hate these things. They get on the Autobahn and their max speed is like 70 kilometers an hour. They're speed bumps. So, they're fun. Basically, we're being lied to, which is no surprise. I mean, everybody selling anything seems to be lying about something. What we really need in the industry and with Newegg and the computer manufacturers and something is the equivalent of this, where if somebody official has come along and said, no, you're not going to claim theoretical bus speeds. You're going to run tests and you're going to tell us what you actually got, what your actual mileage is. That would be very useful when you're looking at a list of 30 motherboards for a 2600K processor. Which one's going to be the best for me? Tom's Hardware. Yeah. Tom's Hardware is nice, but it's not always forensics people. They have different motivations in most cases. So,
AIDE, they get to keep the equipment they're getting.
we can keep the equipment too if you can con the manufacturer into sending it to you. But this is not an open standard. There's nobody putting this stuff out there for consumption like we're trying to do. And what we learned most from all of this testing was that in what we thought was going to be a nice, simple, let's find the fastest PCIe card, and then we can tell the industry and everybody will just use that card, and I will have saved everybody lots of time and money. What we found was that there's about 17,000 other things going on, not 17,000, but a good handful. And trying to make a value judgment on a card, the first thing you come across is what motherboard. The second thing that you come across is what version of that motherboard. And it gets tedious really fast because these guys over in Taiwan that are building this stuff for us, they change chipsets like we change underwear. You can order a motherboard off of Newegg in January, and in February, you're getting a different motherboard. Is that something about you guys in underwear back there you want to share?
He said twice a week.
Whether you need it or not, right?
Yeah. You turn inside once.
So we want the collider, but what we end up getting is this, because we cobble these things together. Now, if you were smart, when you built your last forensics rig, you actually went and talked to somebody and bought fairly decent hardware. If you're in law enforcement, you're dealing with spec and standard and talking to your friends and getting the same thing they did, or you're just buying whatever Firebox sends you. But how do you know that you're getting your best bang for your buck? You don't. And all the stadies that I know don't have much say in the matter. They get what they get, their budget is their budget, and I feel bad. But on the commercial side, we have choice. And there's more of us, and there's gonna be a boatload more of us, because this is heating up in the market. And more importantly, we're engineers and scientists and technical people. If anybody can figure out a way to make this sort of data available in a commercially feasible manner, freely to the industry, it's us. I mean, we put people on the moon. We're geeks. So we've got to be able to figure out how to get the industry to give us numbers that we can rely on, at least better than they are. I'd be happy with Pareto's law, the 80-20. If you give me motherboard statistics and they're 80% right, I can live with that, because right now they're not. They're worse, and that is a problem. When we go to Newegg and we read the reviews and we buy whatever we're buying, doggone it. We see an advertisement for a red car with a horse on it, and we think we're getting a Ferrari. And then we get it, and we find out it's a big piece of junk. And I'm as guilty of this as the next person. When I buy something and it's not living up to standards, I'll just throw money at it. Or when something new comes out and it's faster, I'll just throw money at it. When my first client came to me and with like a 10 or 12 PC job, and they said, we want you to get this done in a week, we just went out and bought PCs. We didn't mess around with it. We just threw money at it and paralleled the process. It was a really easy choice to make back then. But the decision to do process differently or to throw hardware at it or to throw money at it, these are all business judgment calls that should be backed up by some kind of intelligence about the equipment that we're using and the process. It's a cost effectiveness issue. Again, there are slight differences between the commercial world and the law enforcement world, but everything is still, it would be nice to have something faster. It's like those commercials that are on TV right now with the little kids. I'm like, what would you rather have? More speed? Yes, Bill.
There's a question back here.
Wasn't, no. Thought you were stretching.
I was going to ask, whenever you're going through something on the AIDE, sometimes like in, let's say like a solid state drive, have you looked at the reviews to see what kind of real speeds they get on like pressure disk mark and stuff like that?
Yeah, but I also don't trust it because I'm a scientist and the scientific process says I need to know how you got your data. I need to know what systems. I need more data than they provide you in the Newegg type stuff. And I also know that there's false reviews, a lot of false reviews. So if you can't trust it, it makes it kind of hard. Now you can correlate and you can go to Tom's Hardware and you can find other people out on the net that are doing stuff, but it all comes down to how much are you going to trust this guy. And when you're talking an $800 motherboard, I want a lot of trust there for $800, especially if I'm buying more than one unit. And that's what I want. I want that kind of level of trust where you can go to a review site and go, this is the kind of performance you're going to get. This is the way we did it, which is the way we all do it, this standard, this spec, this testing methodology. And if you buy that same motherboard and you repeat those same tests, you're going to get those same numbers. That's part of science, is repeatability. Not, it was a Tuesday and I only had my 150 watt power supply, so we were running a half power, and we didn't energize both sides of the bus or whatever. I mean, there's, you can't rely on it. It's better than nothing, but still. So another thing making this even more complicated is that because of Moore's law and something that I'll call Martin's corollary, because I just invented it, it's more effective to tolerate mediocre performance and upgrade your hardware at the earliest opportunity to the next best guess than it is to actually try and optimize what you've got, because the time frame is so short. My corollary says that any advantage in performance will be offset by billable hours and the approaching war horizon. So as you're trying to optimize and test over this period of time here, by the time you figure out the best way to do something, there's better hardware available. So you just basically wasted that time, unless you can do it in a more efficient manner. If you're testing one thing, and you're testing one thing, and you're testing one thing, and I'm testing one thing, and everybody in here is testing one thing differently, and we're all aware of what's being tested, so nobody's duplicating any effort, wasting time, then we can all take advantage of each other's work, and instead of having to test 20 components to get to the next level of performance, I only have to test one. And the reality is I don't even have to test one because not everybody's going to test, and we don't need everybody in the industry testing everything. We just need a few people. That would get us past the crush of it takes too long to figure out how to optimize it. Back to your Newegg question, how many of us accept what our friends and peers tell us? I put together this rig, it's awesome, it's a Xenon twin processor, this, that, and the other, 32 gigs of RAM. It's fantastic. Maybe he's just floating his own boat. And you definitely can't buy what people are saying in forums, because we all know that there's trolls out there and they tend to say things that aren't true. So because Bob said it's fast, that's good enough for me? That's not good enough for me. I accept Bob's word and I'm running a mediocre rig, and meanwhile Jane is over there kicking my butt because she took the time or she found the right source to go and do things right. Competition is very important in the commercial world. We rely on that stuff. And it's not fun, sexy work. It's not working on an F1 Ferrari. It's banging it out in the garage with your friends, getting dirty night after night, day after day. It's very boring work. Running bench tests on hardware performance is boring. But it has to be done because without the data, you can't make the judgment call. You can't go back on Newegg and go, 5 stars, this thing's awesome. It just happened to be the next generation. Everything in that generation is awesome. You didn't contribute anything with that except saying, buy the latest hardware. But which one's better? Because just with the PCI USB 3 cards alone, there's 4 major manufacturer chipsets. Only one of them works in Linux, which is a problem right there, because now you can't test comparisons under Linux, which means we've removed one of the apples-to-apples comparisons that we can make. And testing everything under Windows, well, that's a flaw right there. So what are you going to do? You got to make compromises someplace. But out of 4 chipsets, which one's going to be the best? Well, we know which one's most cross-platform compatible, so if that's an issue for you, like it is with most forensics people, you've got to have Linux, you've got to have Windows, then you know which one you're buying, you have a choice. But maybe you also want to buy the Texas Instruments. Oops. Not an endorsement of Texas Instruments, because it might be faster. On Windows, you can't use it under Linux. Yes,
I'd
Bill?
like to point out you're using the actual pronunciation of Linux as Linus Torvalds says it's pronounced.
Thank you.
Just wanted to point that out. It's an old school thing, but most people would not even notice.
That's because I started with Minix,
Yeah.
and we know better.
Longest.
So here's the important part of what I'm getting at. When we're working on the process and we come to a stumbling block, we just find a way around it. Throw money at it, use different hardware, change your process. So workaround becomes process, and mediocrity becomes norm, because somebody can do it better and you're not doing it better, but we've told everybody in our industry that this is the way it's supposed to be done. That's the way it gets done. I don't like accepting mediocrity as the norm. I prefer to do things better. Accepting things is an inferior way of doing business. Now, in some environments, having set processes is a good way to do things. Law enforcement, courtrooms, judges, these things complicate what's going on. But everybody upgrades to Firebox. You don't stick with a 386 just because that's what you had and it works. You have to upgrade at some point. Typically, it's forced by bus issues. But if you're not maintaining your competitive advantage, the competition eats your lunch. And I'll throw this out to the LE people, because it's important. If I happen to be the expert on the other side, and I have access to all of this hardware, and I can go through the data much, much more quickly than you can, and I can find things that you didn't find, I can use that to my advantage in defense. I can use that to bring up questions in cross. That's bad. If everybody doesn't have the same level playing field when it comes to the data, and their access to the data, and their ability to process the data, then it's an unfair advantage. And everybody in LE knows that they're always at an unfair advantage because budgets. Can't do anything about budgets. So we want to fix that. No, we're going to. Come on. There we go. So what happens when we're looking at something that we're processing and we come up with data that doesn't look right? When you're running a speed test on something and it comes back, that's USB speed, but you're getting USB 2.0 speeds out of it. Most of us take that card out of the machine, set it aside, take another card, put it in the machine, and hope to get USB 3 speeds. And if we don't, then we look at the 2 cards and we go, oh, it's the same manufacturer, throw them out, we get a different manufacturer, we put that one in the machine, and we proceed with our job, because that's what we're paid to do. We're paid to get to the end of that job. We're not paid to figure out why those two cards are showing USB 2 speeds. But it's an issue. So most of us just turn to a different configuration when we see anomalies. But if we had the time and the motivation, we could figure out what's going on there. If we could figure out what's going on there, we might answer some questions that are important to other people in the industry. Occasionally we come across something we've dealt with, and if we're lucky, somebody posted it on a blog. And you're like, at least I'm not the only one that's got this problem. But it's out there, but you still, there's not enough data. What's causing the problem? And the reason it's important is that everybody in the industry should question these anomalies. Where's that other slide? Because anytime you have an error in what's going on, or a difference in how what you're seeing differs from what somebody else is seeing, you have an anomaly. And where there's anomalies, there's opportunities for somebody. Either you can bring it up as a way to question things, or you can bring it up as a way to identify problem areas. I mean, there's a lot of things that bother me when I'm doing a set process for hardware and data and something doesn't work right. We're going to talk more about that in a minute. But letting errors creep into the process and not identifying them and dealing with them can lead to problems down the road. And the nice thing is that the more we contribute to the public data sets, the more we take advantage of each other's configurations for games. That is a crowdsourced car, by the way, that they built using crowdsourcing. The designs are freely available. You can get them printed up. It's a rally car. Go figure. Neat. I just really, oh, no, it's just that one.
That's stretched too.
Yeah, that's stretched. Sorry. So like I said, when we come across a problem in the processing, we just replace the part. We don't question why. And in an electronics engineering viewpoint, this is one of the worst possible things you can do. Because if you replace that card and you haven't figured out why that card didn't behave, or worse, why that card failed, you may have just fried your second card. And I've literally watched engineers go through boxes of hard drives and boxes of cards before someone said, it might not be the cards. It could be your motherboard, or it could be your power supply, or something intelligent like that. So most of the times it's a trivial cost. Okay, so now we've got one dead, now we've got two dead. We understand what the problem is now, we move on with it. But if it's not electronics, if it's not fried like that, if it's a logic problem, that's a little more difficult to get your teeth into. And testing takes time. Designing proper testing takes even more time, and with more mature resources. I run up against this all the time with my interns in the testing that we're doing just with the PCI stuff. Here's this card, go test it the way we tested the other stuff. They like to take shortcuts. And then you have to go back and redo testing. You need specialists who understand all of this stuff, who say, okay, I understand that we're testing this object, and this is the proper way to test it because of these reasons. You want to test the steering and the angles of attack on this thing? Well, then you need these devices to do so. Just sitting a monkey on there and having him drive around the circuit isn't going to do it. And you need to do your testing right. We need dedication, we need multiple, multivariate analysis, if you will. Why am I testing more than one card? Why am I testing all the cards? Why am I testing more than one motherboard? Why am I testing the different drives? To show that this thing has layers to it that most people aren't aware of. I want USB 3. Here's your card. That's not the end of it. You've got to have the rest of the numbers. Then there's the whole Windows versus Linux. What about Windows 7 versus Windows 8? What about Windows 7 Release 1 or Revision 1 and Windows 7 Revision 2? We've all seen Microsoft step on their toes by releasing a patch that does bad things. I mean, remember a couple years back when McAfee released an update and it like took down entire networks? Mistakes happen. Big ones like that are easy to see. The iPhone update a year ago. So if you install as many PCI boards as I have in the recent months, one of the things you find out is that sometimes you install one of those drivers from Taiwan that has barely readable English, and all of a sudden your primary forensics box stops working. Which of course, since I'm a professional, we just rewrite it over, but it's still, it's a wake-up call. There's stuff going on in this box that I'm not completely aware of. There can't be, it's too complicated for everybody to know everything. But it would be nice if somebody out there in the industry was looking at that PCI driver to find out what the heck is going wrong, find out what they're doing. And if you're in the State Department, it's really nice, because who knows what that IP stack modification just did. We all know about corporate espionage. We go through a lot of hardware, we go through a lot of software. Strange things happen. I like to know why. Different topic. We can talk about that at HackerCon next year. So what else might be nice? Free replication of that data to non-commercial sites. That's great that Tom's Hardware has that stuff available, even if it's not perfect, it's still better than nothing. What I'd like to see is something more along the lines of a laboratory where stuff is published, university affiliations. It's not, and if you have sponsorship from commercial sites, it's available so that we know who's buying who. The organizations in the forensics world that I would normally expect to back something like this, where you have a data repository that we all have access to, they all are compromised by commercial interests. I'm not going to name any names, but everybody's got donations. They aren't publicized, and you can't trust them. Not 100%. Most of them are trustworthy enough, but not the way I'd like to see things. So the thing that prompted all of this was my friend Joshua and I were working on a case in our backyard, civil litigation case, and we were running checksums on drives using USB 2 dongles, and we were using multiple dongles because it was a multiple drive case. And one of the dongles produced a checksum that was different than the other dongles. And I don't know how much you know about IDE mapping and what goes on between this hard drive and that hard drive board and this interface card and this interface board and that PC and that bus type and the drivers that are in there. But on the forensic side, it's really damn important that those numbers never differ. Because if they do, I can walk into any legal case in the world and go, checksum's wrong, tampered with the data, dismissed, we're done. So this got our attention, but we were on a deadline. What we did was take that dongle, set it over here, get another dongle, and continue on our merry way. And the first thing I thought of was, let's test the dongles. The dongle got crushed, so we couldn't test the dongle. And I didn't have another one like that, and you can't buy them anymore. But something was going on there. When two forensics guys are looking at the same problem and both saying, yes, there's a problem, and we did recheck stuff before we went and got another dongle, there was an anomaly there that cropped up. And it was like watching The Matrix. There's two forensics guys looking at a checksum going, ooh, this is not good. And we still don't know why, because we couldn't get the data out of it. So we just started over again. We started with PCI cards, trying to see if we could find other things like that that would lead us down a path of inquiry to, hey, there's stuff going on here that forensics people need to know about. Haven't found it yet, but we have found a lot of performance anomalies, which takes us to the commercial world. I try to use my interns when I'm doing this stuff because they're cheap, it's good work for them. They can't work live cases. They gotta have something to do. It's training in both the tools and the scientific method and in the brutal, boring slog of what is forensics work. It's not CSI, we all love pointing that out. Life's not like CSI. No, it's not. But you have to babysit interns because they don't know everything.
They're interns.
Yeah. The only thing that we found to be worse than slogging through boring data is having to slog through it the second time because we didn't do it right. Standards is what we need, standards and testing. We developed our own test suite for the PCI cards. This is how we do things. And when we say test suite, what we really mean is a script that's like 2 lines long. Actually, it's like 20 lines long, but either way, it's just a stupid shell script. It's not like we went and wrote one of the CPU performance testing pieces of software that actually has like serious code behind it. It's just a shell script that times stuff, but it's all we need. It'd be nice if it was out there and if you said, I want to test my hard drive and my PCI card because he said some things that were kind of boring, but I'll just test it because I'm bored. It's there, so you don't have to rewrite it. You don't have to reinvent the wheel. That's always been big with us software people is don't reinvent the wheel. And then somebody decided to start copywriting software. We need these standards, we need these data. Unfortunately, research is expensive, which is why I think it's important that we spread it across the industry. It has to follow the scientific method, it has to be repeatable. That's really important. Just a slide. Gotta have NASCAR in there. Competition from different sources will improve our chances of actually accumulating valuable data, and championing things like this gives you free publicity. If you're a school, if you're a Marshall, why isn't Bill in here? This is my pitch. Dang. Anyways, if you're a Marshall or if you're an ESU or a Carnegie Mellon or whatever, and you participate in something like this, the data comes out and it's Carnegie Mellon tested this. Marshall University tested this. This is their data. It's free publicity. And when you, as a prospective college student, are looking at stuff, who are you going to go with? A university that participates in the field and provides data and testing and projects and fun stuff like that, or somebody who's like, oh yeah, we have a forensics degree. I think. One teacher, yeah. You're going to go with the shiny one. You're going to go with the people that are popular, the people that are contributing the most. The other thing is that those universities and those companies that are contributing to the industry in this way are going to be the ones with the connections, because you can't do this stuff alone. Connections are what gets us jobs. Employment is kind of important right now. Not so much on the forensic side. It's like there's no shortage of work. Swinging dead cat type deal. But we've got lots of people that want to come into the field. You can't get into the field without help. Not the right way, because there's all this stuff that you need to know. So contribution works on it. Yeah, we finally got to the memes, by the way. I don't think Bill's not here for. This whole thing that we're talking about with data collection and testing is a team effort. You can't do it by yourself. I can testify about that because I've tested a bunch of PCI cards and a couple motherboards, and all I found is that there are more layers that we haven't tested. We haven't even looked at the drivers or the versions. Our testing is, it's Windows, it's fully patched, it's Linux, Ubuntu, it's fully patched. Every time a patch comes out, we apply it. We don't worry about DLL changes, versioning, things like that. I got enough things to worry about hardware-wise without worrying about the OSs. But as any scientist will tell you, you just invalidated your test data. So, sorry, it's the best we can do. But we need more people. Marshall's going to be donating money to a soon-to-be-named public organization for research. Appreciate it. Thanks.
Well, really? Great. He was here from Marshall. Well, I see how that works.
So the most important thing is that we're getting the data that relates to what we do. Like we talk about Tom's Hardware and places like that, Newegg, the reviews. That's not specific to what we do. I want a forensics guy telling me we ran these tests for this reason and this is what we got. And another guy saying, yeah, we did the same thing, but with this piece of hardware, and this is what we got, because that's what's important to us. I don't care about how many pixels you can throw up on the screen. I don't care about how many GPUs you've got. Hashcat is not my everything. My everything is data throughput on the bus. That's what's important to me. So I want to see that kind of testing. And you can't get that anywhere. It doesn't exist. The problem is that the gamers have screwed up the environment. Somebody a couple years back pointed out, if we put the amount of money into medical research that we put into games, we'd probably have cured cancer by now.
Oh, it's fun though.
It is. It is. Gamers steal all the fun. The other motivation here is selfish, and we should all have it. Knowing what to buy, or at least knowing what not to buy, saves us resources. Not just the money that you save, but the frustration of having to go back and redo stuff, or the frustration of having to rebuild stuff. Nobody likes to do stuff twice. Be told they did it wrong, do it over, especially if it involves cutting another check. That makes it even worse than just having to do it over again. The other thing that's nice about it is if we all are operating on this kind of imaginary data set that we've been talking about, our environment's standard. When you go from company X to digital trust, or from law enforcement to commercial work at Smith Barney, or whatever company doing forensics, everything will be the same, or essentially the same. Your tool sets will be the same, your processes will be the same. I'm fairly certain that every single federal office in the United States does things exactly the same way. I'm pretty sure that most of the state offices, the states, at least within the state, do things exactly the same way, if not state to state, because, well, we do talk to one another occasionally. I know for a fact that the commercial side of forensics differs from place to place. And tool choice is based on personal bias of the owners of the company, not on anything intelligent like actual performance metrics. It should be based on performance metrics, because as a company owner, I can tell you, I'm interested in that because it saves me money. But not all the time. Somebody came out of the state system, and they were doing things a certain way there with a certain piece of software, and now they're starting a consulting business. They're going to keep using that piece of software because that's what they know. What they don't know is that that piece of software is a piece of crap. Unfortunate, but that's what they're going to encounter in the real world, is somebody coming along going, oh, that? Yeah, we're about 400% faster than that, which means we can do the job cheaper, which means you're not going to get the job, which means you're not going to be a consultant for very long. It's nice when you're in the government position and you're shielded by what you've got and you have to deal with what's there, but out on the other side of the fence, it's a whole different dogfight. I'd like us all to be using the same stuff. That would also force the people who aren't doing things right to do things right. Those vendors that are lying when they sell you stuff and say, we're the best, we've got the fastest throughput, you can do network collections with us and it'll kick butt. Lies. Make them do it right. You can't do that unless you're forcing the competition upon them. And that's what I want. I don't want them to go out of business, I want them to get better. This is the way to make them do that. I spent 3 years fighting mediocrity with my tool set because one day I was just fed up. And I said, there's got to be a better way to do this. Ironically, the first person that I talked to, the boys down in Louisiana, you guys rock, gave me the answer. And I ignored it for 2 years because there was no way in hell that the best forensic tool set and process out there was that cheap. It wasn't free, but it was cheap. There was no way. So I went through all of the major names and came away ultimately dissatisfied, and went back and tried that one. And it's so cheap that they won't even give you a trial copy. They'll give you a 90-day PO or a 45-day PO or what have you, but you're going to pay for it. Put it on a credit card, it's cheaper. It works like a charm. It's amazing. It's made my life so much better. Instead of having to fight through the tool set. How come everybody's not doing it? Because it's the way we've always done it. Well, I got news for you. It's time to change. Notice I'm not naming any names, no sponsorship here. Yes, Bill?
I know we talked about this a little bit yesterday, but what's your view on open source tools?
I love open source tools. They're just not as fast as what I'm using. Not nearly. How many slides are there? Oh, good, we're in good shape.
I should say open source forensics tools.
Yeah. I actually prefer that because again, you can come back and look at the code and you can prove what's going on and so on. So if you could spend 50% more time looking through evidence or clear cases 50% faster, that would be valuable. That's what it can amount to, 50%, 75%. The thing I look at on the commercial side, because we're dealing with litigants, is it gives me that much more time. I can be doing analysis. I can be looking for the smoking gun. I can be looking for the thing that disproves the smoking gun. That's valuable client time. That's best serving my client. If you're not making that effort on the litigation side, you are doing a disservice to your client. On the lawyer side of things, we call that being a bad lawyer, and we punish that by taking away your bar credentials, and you don't get to practice law anymore. You must be good to your clients. But at the same token, when you're hiring experts, you should hire ones that are actually experts and not people who are just going through the motions, or worse, pretending. This stuff helps clients. By clients, we mean litigants. Huh? Did I double click again? Yep. Okay. And oddly enough, what some of us do is really esoteric, especially on the commercial. Well, I don't know, the LE side gets into this too, but not to the same extent we do, I don't think. We deal with some really esoteric hardware. On the LE side, they deal with new and innovative ways to use existing hardware. The messaging bit on the Xbox a couple years back, that was clever. I like that. When's the last time they had to go into a closet and dust off a 20 megabyte MFM drive? Does anybody here know what an MFM drive is? Wow, okay, thanks. It's one of the first types of commercial hard drives. 20 meg was huge back then.
And around $1,200.
Yeah. Big rusty iron platters, great. But how do you access that data? It's client evidence of something. They pull it out of a closet, they hand it to you, and you're like, what the? I know it's a hard drive, but how am I going to plug this in? Well, you're not, because you don't have anything to interface to.
Like running exploits against old operating systems.
Well, that
The exploits aren't available anymore. You
gotta rewrite them. But it was so easy back then that it's not that hard. You've got to have a computer that supports the I can't remember what it's called now, the ISA bus. The old 16-pin 286 card bus, and then you've got to have the MFM adapter, and you've got to have the right ribbon cable. Then you can get data off the drive. Now, how do you get it off that computer? I just pull a USB stick. There's no USB sticks on there. If you're lucky, you find somebody that has an ISA card with an adapter that you can use, or you figure out how to do serial communications using old 9-pin at 9600 baud or 9600 BPS. So there's esoteric stuff in there that gets strange. That's what community's for. That's what I like, having this information available. Where we at? Okay. So there's strange stuff that you have to know. It's nice to have experienced contacts. That's what this stuff is all about. New people entering the field need to know what tools to use. The pitch in school might not be enough to use in the real world. If you get trained in school on how to use product X, and then you come out into my world and you want a job, and there's another guy who knows my products, which one of you am I hiring? Duh. So we want to train you on the right stuff. And what we're talking about, you guys, you need to see that one. Okay. What we're talking about here is something like what UL does, Underwriters Laboratory. Everybody's familiar with the UL logo, you probably don't understand everything that they do, but they basically test the hell out of everything that's dangerous. And they do it in the right way, so you can trust it. When it's got a UL socket on it, you can plug it into the wall and it's not going to fry you. We want that kind of stuff for us, but not Underwriters Laboratory. Something we can trust backed by verifiable data. cooperation, contribution, improving the field, publication, glory, immortality. Do we have to have this data set, this data repository of reliable data for what we do? No, but if it were there, would any of us not use it? You'd be an idiot not to use it. You'd have to use it because your boss would come in and be like, why didn't you buy the stuff they said to buy? And if you turn to him and say, well, because I did independently verified testing and I found that this is better. And he'd be like, well, why didn't you publish it up there? We need this, I think. I think it saves time, it saves money, and it improves client outcomes. And that's what's really important, is that this is what we have to do for our customers. The right stuff. And if anybody wants to talk more about this data thing or where it leads in terms of legal testimony, that's how you can get in touch with me. More questions?
I've seen, you know, I come from the breaking into stuff side, and I'm kind of new to the digital forensic side.
By which
but
you
I
mean
see-
pressing autopone and getting a beer?
Exactly.
Yeah.
DP autopone, getting a beer, and also running Nexus, but anyway. But I noticed that you sort of have to jump through a bunch of hoops with the forensics tools just to do simple things. You know, would you think, this is your personal opinion, if you did something like Loop Interpreter and did a hash dump in order to dump the hashes and then crack them, would be forensically sound instead of going through this $20,000 program in order to get the same information? Has that ever been tested in court as far as you know?
For starters, this is a common misunderstanding that comes up with hashes and evidence. Cracking hashes is not the same thing as the hash being correct. There's absolutely zero problems
I'm
with
talking
relying on
specifically
hashes.
about passwords, not hashing file sizes, but passwords.
Oh, and then I don't understand the question. Can you rephrase? What, is there a problem with it?
Well, you know, I'm looking at unnamed commercial forensics tool, and it's a 14-step process in order to basically dump SAM hashes
Uh-huh.
and then crack them.
Oh, yeah, because we have easier ways of doing it.
We have easier ways
Yeah.
of doing it. It's going to save your time, so
Yeah.
therefore, you know, you'd have more time to actually look at what you
No,
have.
what you do in that case is you make a clone. You play with the clone using whatever tool of choice you have. You figure out what the password is, and then you go back and you see if there's anything worth pursuing. And if there is, then you go back and pull the hashes and walk them through the process. If you have to deal with some sort of formal process like that, yeah, you figure out the
Because I
shortest
sat
way.
there and watched the training, and the only thing I can think of is I can do this in 2 minutes.
Yeah,
Or I can do the same thing you're doing, but you're using this convoluted process that costs a lot of money, so.
yeah.
That's just my view of it.
It's not always
my
the most efficient.
perspective, yeah.
Because the legal community recognizes that $15,000 software, not the.
No, I understand
open
that.
source.
I understand that. And Marshall is one of the few colleges, I think it may be the only one that is, has the FEPAC certification in digital forensics. You know, it's all
That's the
about
only reason why he asked
making
this
your,
question.
validating your tools, et cetera.
Yeah, it's advertising.
It's all about validating your tools, et cetera. And I understand that, but also from the open source community, sometimes I wonder, you know, are we missing something when we teach our students only commercial tools?
No, I mean, yeah, you are missing something if you teach them only commercial tools, because they'll have to learn all of that other stuff. The thing is that 99.9% of all the work on the commercial side never sees the light of day.
Right.
It never even gets brought to deposition. It never shows up anywhere. In fact, most of the times you don't even do it. You do collection, and then it
Settles
sits
before
there.
they ever get there.
Yeah, it sits there and gathers dust, which I'm fine with. But when you have to do it right, and it has to go to court, you have to do it the way the court expects. That's where experience comes in. That's why it's nice to hire former LE people, but on the commercial side of the things, we can do things differently.
Or you have to at least be able to explain why you didn't do it.
Yes, if you've got a solid explanation, then you can go with that, and you're good to go. But I wrote a cracking tool and yanked the hashes, that's probably not gonna cut it. Yeah, you'd have to go back and do something that at least could be repeated. And that's the nice thing about if you're doing it right, you know, they can always say, well, we don't accept that. You can say, fine, we'll do it the other way. Unless you get some snotty judge who's like, I don't have time for this, get out of here. Sorry. Other questions? Who's gonna contribute? Oh, come on.
I just sent you an email.
Oh,
Just
sweet.
kidding.
All right. Well, thanks.
Thanks.